Is it possible that Earth is actually just an experimental base? Maybe an alien civilization has long regarded us as test subjects and is observing our every move. The problem is, we have never received a response from any alien civilization. Is this really just a coincidence? Or is there another reason? Did they choose to remain silent because we have not reached a certain level yet? To be honest, there are just so many questions about alien civilizations, but to truly uncover the truth behind them, I am afraid we need to re-examine the very rules of the universe. In the next 50 minutes, I will take you on a deep dive into all of this. Let us see how these hidden truths can change our understanding of the universe. Whenever the existence of alien civilizations comes up, bet everyone thinks of a classic scene. That was in 1950. Nuclear physicist Enrico Fermi was having lunch with his colleagues when he suddenly posed a thought-provoking question. If extraterrestrial civilizations really exist, then where are they? This question ultimately sparked one of the most puzzling debates in the universe, the Fermi paradox. Fermi paradox. The Fermi paradox. Although the probability of extraterrestrial civilizations existing is extremely high, we still have not found any definitive evidence. One possible explanation is the zoo hypothesis. It suggests that alien societies already exist and are fully aware of who and where we are. But they have chosen to deliberately hide themselves, as if we are animals being observed, and they are like invisible observers in the universe, silently watching our every move from behind the scenes. But the intentions of these alien civilizations might be far darker than that. If you are a fan of Star Trek, you might remember the Federation's fundamental rule. Starfleet officers must not make contact with species that are not advanced enough so as not to interfere with their development, even if it means risking their own lives. Although this is just a fictional story, this rule perfectly illustrates the core of the zoo hypothesis. Life forms from the other end of the universe might see our planet as a cosmic zoo with a one-way fence. They can watch us brush our teeth in the morning or walk our dogs, but we can't see them. In this theory, extraterrestrial life is deliberately keeping its distance from us, following a policy of non-interference and maintaining separation from our planet. It is as if those superintelligent civilizations have reached a consensus. We should have the freedom to shape our own future and develop at our own pace, without external interference. Perhaps these highly advanced civilizations are already 500 million years ahead of us. This also explains why we have not found any trace of them so far. Maybe that is actually for the best, because humanity could ultimately be destroyed by this new cosmic force, or even assimilated. Like the aliens in Independence Day, they could assimilate us. Although activities like visiting an art museum might be fun for us, but for aliens, this might not be all that appealing. After all, the way they see everything about us might not be with the same interest and curiosity that we have. Interstellar civilizations might prefer to quietly observe how we develop new technologies, such as ultramodern satellites. According to the zoo hypothesis, alien civilizations will only actively contact us when we reach a certain level of development. Advancing our technology and intelligence might be the only way to prove to them that we are mature enough and no longer need their parenting. However, there are several reasons why it is hard to fully believe the zoo hypothesis. Alien civilizations might simply choose not to contact us because we are still not advanced enough, but that does not explain why they completely ignore all our attempts at communication. Even if zookeepers try not to interfere with the animals' lives, I bet they still would not ignore a bear that clearly and fluently expressed a desire to communicate. That is also why humans keep trying again and again to reach out with radio signals. Establishing contact with inhabitants of other planets has never received a response. In 2017, 8 miles southeast of Trondheim, Norway, a radar antenna transmitted carefully composed electronic music to potential interstellar listeners. The target was GJ273, also known as Lytton Star. This star is located 12 light-years away from our solar system. It is a small red dwarf star. Because radio waves travel at the speed of light, we will have to wait over 20 years before we can expect a reply. But there is a major problem with radio waves. We do not actually know where to look. Civilizations could be as far as 17,000 light-years away from us, and we also can't be sure what frequency aliens would use to communicate. On Earth, send signals into the universe using radio waves. Assuming this method works for us, it might also be a universal approach for other civilizations. But in reality, this could be an outdated technology for alien life. That is why some research projects have started searching for other technological signatures, such as city lights, solar panels, megastructures, or artificial satellites. Another potential clue is to study the atmospheres of planets around nearby stars. Advanced civilizations might alter the composition of their atmosphere, make it detectable by us. Despite decades of observation, We still have no conclusive evidence of advanced extraterrestrial civilizations, but that does not mean they do not exist. Even if we expand our search, the chances of finding an advanced civilization remain extremely small, about 1 in 3 billion, maybe. Life in the universe is responding to the signals we send out. We can't understand their way of communicating. The universe has existed for over 13 billion years, while humans have only been on Earth for 200,000 years. That is just 0.01% of the universe's age. It is as if we are still learning to speak. Even though other super-intelligent life forms, they might be transmitting information in ways we can't possibly understand. We are still waiting for a giant flying saucer to land, with green aliens stepping out of it. But we have overlooked another possibility. Interstellar neighbors might actually be more interested in using nanotechnology to monitor us. They might be trying to communicate using neutrinos particles with extremely small mass that can easily pass through our planet and not be detected by our current technology. At this point, the zoo hypothesis faces another challenge. It is hard to believe that so many civilizations in the universe would all decide not to contact humanity. For this to happen, there would have to be a highly structured presence in the universe, a higher intelligence acting as the leader of the universe, giving orders to other civilizations and setting rules to keep us isolated from other civilizations. But after all, what we are discussing is the possibility of billions of forms of life. More civilizations also means more chances to break this non-contact rule. Therefore, it is very likely that at least one planet is just like us, eagerly searching for life in the universe. Some scientists believe, if advanced life had already colonized Earth and other planets on a large scale, we should have noticed it by now. There are two even more unsettling variations of the zoo hypothesis. In the laboratory hypothesis, no one contacts us, because humanity is actually part of an experiment. Earth is essentially a giant scientific laboratory. Creatures from other planets might be observing us, analyzing how we respond when humanity faces survival challenges, like tsunamis and major earthquakes. In such situations, the non-contact protocol between alien civilizations makes even more sense for them. Doing so is for the greater good of scientific research, at least from their perspective. That is indeed the case. Another hypothesis is the planetarium hypothesis, proposed in 2001. Some believe that we actually live in an artificial universe, a kind of virtual reality that gives us the illusion of a vast, empty cosmos, but that is not really the case. However, there are currently no possible tools to verify this hypothesis, apart from the zoo, laboratory, and planetarium hypotheses. There is another theory that can explain the Fermi paradox. Some people think that no one has contacted us because humanity is completely alone in the universe. This is the rare Earth hypothesis. It emphasizes that Earth is in an extremely unique position. No other planet has any conditions that could nurture life more complex than bacteria. We might think of ourselves as very lucky, because even a small change in any of Earth's orbital parameter, such as the distance between Earth and the Sun or the rate of Earth's rotation, would make the conditions extreme, unsuitable for humans or any form of life to survive. But once again, thinking about whether we are alone, especially in such a vast universe, is truly very difficult. We come back to the big question. Where is everybody? Are we really drifting alone in the universe? This question has troubled us for centuries. Scientists have tried to propose various theories to explain why we have not made contact with other life forms. One of the strangest theories is the dark forest theory. It explains why we have not encountered alien civilizations. Let us start with a relatively small scale, such as our own galaxy. To better understand this theory, our cosmic neighborhood is an interstellar wonderland, scattered with 200 billion twinkling stars. There may also be around 100 billion planets. Suppose that life exists on just a small fraction of these worlds. Among these distant life planets, perhaps some have already evolved intelligent beings. Based on this assumption, you might think we should have already encountered some strange neighbors. Some of them might be actively looking for us, or just waiting to be discovered. Now let us add a bit of science to this sci-fi scenario. We have something called the Drake equation. It is a universal calculation tool, used to estimate within our galaxy how many intelligent civilizations there might be. You can think of it as a super-intelligent roadmap of the universe. By adjusting a few key variables, this equation will tell you there might be at least 20 civilizations in our galactic neighborhood. So here's the question: if they are supposed to be nearby, why have not we seen a single one? This equation is not simple. It takes a lot of variables into account. For example, how many planets in each star system are suitable for life? What is the rate at which stars are formed? How many forms of life will eventually evolve into intelligent beings? Unfortunately, astronomers still can't provide precise values for these variables. What we put in are just rough estimates. Even so, As long as we use these assumptions, we can still reach a general conclusion. There should be dozens of civilizations in the Milky Way, but the problem is our radio telescopes have been listening all along. The universe remains completely silent. This silence is at the very core of the Fermi paradox. Its name comes from the man who, during lunch, asked, "Where is everybody?" That man was Enrico Fermi. From that moment, humanity began a chain of speculation. 6. Some say it is because life itself is extremely rare. Others believe the hard part is not the emergence of life, but evolving from bacteria into a highly intelligent civilization. There are also those who think civilizations always end up destroying themselves before they can mature through nuclear war, climate collapse, or technology running out of control. But there is one theory that is even more chilling than all of these. This is the dark forest theory. According to this theory, the universe is like a vast forest. Invisible hunters are lurking everywhere. Every civilization is like a creature in the forest. It has to stay quiet, because you never know if something is watching you in the darkness. Why are they silent? Because it is uncertain whether you are a friend or foe. If there is any chance you could be a threat, the safest approach is strike first. Eliminate you to ensure their own survival. This is the universe's version of a survival game. In this scenario, establishing contact with an alien civilization is actually the most dangerous move because you have exposed yourself. It is like turning on a light to tell the hunter, "I am right here." So every civilization learned to keep quiet and hide. The universe fell into a kind of oppressive hushed state. No one dared to make a sound. Everyone is waiting for someone else to speak first. Everyone is afraid they will be the next target to be wiped out. Sounds like science fiction. That is right. The first person to elaborate on this theory in detail is actually a Novelius Sixon's The Three-Body Problem, but this idea was actually proposed even earlier by the scientist David Brin. He believes the reason we have not heard extraterrestrial radio signals for so long, maybe it is precisely because once it is spoken, there is a risk of being wiped out. Even speculated that maybe the hunters are not even organic beings. Instead, it is a kind of automated machine civilization, executing a remove potential threats program across the universe. Sounds crazy, but the scary thing is this theory does not require all civilizations to do this. As long as there is one sufficiently powerful hunter civilization, the others would choose silence out of fear. This might explain why, after listening for over 100 years, we still have not received any advanced signals. It is not that no one is speaking out, but that no one dares to speak out. But this theory also has its flaws. It is based on one assumption, that alien civilizations think like us, the same level of risk aversion, and share the same values as humans. Or perhaps there really is a rogue civilization, actively hunting down any neighbors it considers dangerous. That is quite a big assumption. If you think that is already shocking enough, then what comes next might really send chills down your spine. For about a century now, we have been loudly announcing our existence to the universe. If this theory is correct, then a civilization 100 light-years away from us may have already received our signals and knows exactly where we are if we have a reason to hide ourselves. Just as Stephen Hawking suggested, we might already be in trouble. But what if this theory does not hold? What if strange galactic beings are actually trying to contact us earlier than we imagined? In fact, most people do not even know what to do. Do not be too arrogant. In reality, some scientists have already started addressing this issue. Since the 1980s, experts have been trying to write a guide to tell us how to respond if we make contact with our cosmic neighbors. For example, some researchers believe we should not just worry about how these life forms might disrupt our world. If they send us any radio signals, we also need to consider how to respond. What should we say? "We are humans. Nice to meet you." Absolutely not. We have to do better than that. Up until now, our only plan comes from a rough blueprint from 1989. It offers some vague suggestions about what to do if the whole world receives a message from aliens. The advice is pretty unclear. Most of it just says, we need to tell everyone about this, and then what if we confirm the message is real? The government is supposed to consult the United Nations, but does the UN actually have a plan for this? Who knows? We have indeed been conducting a lot of space exploration recently. Some people say we have discovered water on Mars. Others are convinced we have found planets that might be similar to Earth, so the idea of finding life elsewhere is not all that far-fetched. But even after 100 years of trying to communicate with life in the universe, we are still the only ones speaking. This new protocol is not just about chatting with aliens. It will also serve as our cosmic voicemail, examining messages from outer space. It is not just about decoding alien languages, it also involves figuring out what these messages mean for us. This plan also includes writing reports, analyzing the impact of different policies, as well as developing guidelines on how to respond to these space messages. Will we really receive messages from our cosmic friends? Only time will tell. But what we do know is that absolutely cannot be unprepared. We can't wait until we receive a message from aliens for the whole world to start panicking. We need to have a plan and be ready to face a real extraterrestrial civilization. What I mean is, although we have encountered many potential sightings before, none of them have been real. Authorities have investigated over 100 cases of aerial anomalies. I won't go into details, but not a single green creature has been found. They are more like drones, or something similar floating around, standing at this moment that could change everything. We have to be prepared. Whether our interstellar neighbors text us tomorrow, or centuries from now, we need to have a plan. After all, this could change our understanding of the universe, and all our understanding of our place within it. According to the panspermia theory, life may have been delivered to Earth by meteorites, comets, or asteroids from different regions of space, brought to Earth. Although this theory is still purely hypothetical at present, we can analyze whether it might be possible. Traditionally, astrobiologists searching for extraterrestrial life have focused on. We have been exploring Mars, the possibility of life in the subsurface oceans of Saturn's and Jupiter's icy moons. But in fact, simple forms of life might be even more widespread. They could be floating right now in interplanetary space, existing as dormant bacteria and spores. Several scientists have pointed out that the extreme environment of space could severely damage these spores and the dune and wren of microorganisms. However, some other scientists believe that enough microorganisms might be floating in dust clouds, and that some of them might survive in their primitive forms. There are several different versions of the panspermia theory. For example, lithopanspermia suggests that certain forms of microbial life might be blasted off during collisions between planets and their moons or asteroids, ejected into space, becoming fragments drifting through the universe, and eventually arriving on Earth. Radiopanspermia, on the other hand, suggests that life forms might rely on radiation from stars to travel through space. However, the question is, how do ultraviolet and X-ray radiation, combined with the vacuum of space, not completely destroy microbial life? There is also a theory called pseudo-panspermia. According to this theory, the organic building blocks of life might appear in interstellar dust clouds and then be delivered to planetary surfaces, where life then begins to develop. Does sound really interesting, but is there any evidence to support the theory of panspermia? Well, in fact, some orbital experiments have already been conducted. Between 2008 and 2016, samples were collected using specialized exposure equipment. The main focus was astrobiology. These devices were installed outside the International Space Station, deliberately exposed to space conditions. Afterwards, the samples were brought back to Earth for analysis. The results showed that some of these samples successfully survived these extreme environments. There was even one experiment where 100% of the bacterial spores survived under simulated Martian conditions. Even more surprising, some seeds survived in space and grew into plants after returning to Earth. The Long-Duration Exposure Facility satellite and the Russian Bayan capsules bioplate experiments also showed spores, lichens, even tiny animals like tardigrades, can survive in space for years. In 1969, the Apollo 12 mission brought back a part from the lunar lander Surveyor 3 to Earth. Astonishingly, it actually contained a strain of Earth bacteria. These bacteria, without any protection, on the surface of the moon, this airless place, it actually survived for more than 2 years. Of course, it is also possible that this strain of bacteria was brought back to Earth through laboratory contamination. Meanwhile, the Indian Space Research Organization also conducted a search for microbes in space. They used balloons to collect samples in the stratosphere. The results showed that samples taken from air above 25 miles revealed interplanetary cells of life. Normally, air from the lower atmosphere can't be transported to such heights, so this discovery seemed to further support the panspermia theory. But in 2010, when NASA sampled the atmosphere before and after Hurricane Earl, they found that under certain conditions, bacteria from Earth can indeed be carried to very high layers of the atmosphere. However, the main argument against the panspermia theory is that if this theory were true, then any life found throughout the solar system would share a common origin and possess some major biochemical characteristics in common, such as the genetic code. But this does not seem very plausible. In fact, many experts believe only when astronauts personally land on planets like Mars, Europa, or Enceladus, can we truly answer the question of whether life exists in the solar system. This way, astronauts would be able to compare any life forms they discover with Earth-based life. This could be the ultimate test of the panspermia theory. However, until a probe finds direct evidence of extraterrestrial life, this theory remains unconfirmed. If we turn to the multiverse theory, things become even more complicated. If this theory is correct, then we are not the only universe in existence. This idea is both exciting and unsettling. Of course, not all scientists accept this dizzying concept. To be honest, the idea of making contact with a parallel universe, it sounds as unrealistic as winning the lottery while riding a unicycle. But it is worth noting that this concept is no longer limited to the realm of science fiction. Some scientific theories actually support the existence of parallel universes. This has sparked intense debate in the scientific community. Imagine the universe we live in is already mind-bogglingly vast. Scientists speculate our universe contains billions, even trillions, of rotating galaxies. Each galaxy is filled with countless stars. Some researchers have even suggested that the diameter of the universe could reach an astonishing 7 billion light-years. Some even believe that the universe might be infinite. So are there other things we have yet to discover? Some scientific theories in reality are exploring the universe more than just what we see. They may even coexist with, intersect, or go beyond our universe. These fascinating concepts of multiverses and parallel worlds are often intertwined with more familiar scientific ideas, such as the Big Bang theory, string theory, and quantum mechanics. To understand the world outside, we need to rely on theories we have more confidence in, right? Let us go back to that moment 13.7 billion years ago. According to the Big Bang theory, everything we see today was once compressed into a tiny singularity. If the Big Bang theory is correct, then everything exploded in that instant. The universe expanded at a speed faster than light. It grew to its current scale in less than a second. The way the universe expanded led some clever researchers to question, could there be multiple universes? They wondered whether this sudden and dramatic expansion ended everywhere at the same time. Although we know the universe expansions stopped 13.8 billion years ago, and the universe we see from Earth has already reached its current scale, but in some mysterious corners, the process of expansion may still be continuing. Some theoretical physicists suggest that when expansion ends in one place, a new bubble universe will form. The problem is, you can't just hop from one bubble to another like an interstellar traveler. These bubble universes are expanding infinitely. Their edges are moving far faster than the speed of light, and they are rapidly moving away from us. This makes things even more confusing. Suppose we somehow managed to reach the edge of our local bubble and encountered the next universe. Then, these same theoretical physicists also mention, neighboring universes could be completely different. They might have entirely different physical laws. It would be an extremely strange place for us. Following this line of thought, some people believe that in this vast bubble multiverse, there might even be life forms like us. The question is, we are getting farther and farther away from them. Our paths will never cross. Moreover, some very smart researchers trying to connect parallel universes with quantum mechanics. Quantum mechanics is basically a complex mathematical model describing extremely small particles. According to its theory, these particles can exist in multiple states at the same time. They are called wave functions, which contain all sorts of crazy possibilities. But here's the problem. When we observe these particles, we can only see one of the results. It is like the universe is playing hide and seek with us. There is a theory called the many worlds theory. It says, whenever we observe a result, another universe pops into existence. A different outcome becomes reality. It is as if our universe is a giant tree, constantly branching into countless versions. These parallel universes cannot merge, so you do not even know if there is another you, living a slightly different, or a completely different life. The multiverse theory is incredibly bold and very difficult to prove or disprove for science. This is not easy, because scientists like to test their ideas through experiments. However, if the universe really is infinite, why could not there be an infinite number of universes? Try to imagine the universe as a gigantic cosmic playground. Some experts believe that if the universe is truly infinite, then its fundamental elements can only be arranged in a finite number of ways. Eventually, certain patterns must repeat. If this is true, then, perhaps somewhere out there, there could be another version of you, living a life exactly like yours, even having the exact same lunch you had yesterday. But do we have any evidence to prove the existence of these parallel universes? Some people say we do. Have you heard the mysterious story of the man from Tord? It is about a man who appeared at a Japanese airport, claiming he was from a completely unknown country called Tord. Some people believe this is evidence of time travel, while others think it is proof that he came from a parallel universe. Even though you might really want to believe this story is true, the problem is with this place called Tord. Why have you never heard of it? Because there simply is no such place as Tord, whether it is today or back in the 1950s, when this incident happened. That man mysteriously disappeared on the second day after arriving in Japan. Let us go back to that day in July 1954, when the man claiming to be from Tord supposedly landed in Tokyo. He was described as a bearded man who spoke French. So far, nothing seems too bizarre, right? But according to different versions, the story starts to change. In one version, when the man handed over his passport to be stamped, the Japanese officials' eyes widened. Even though the passport looked legitimate, the country listed as Tord was one no one had ever heard of. Both the officials and other staff were confused, so they decided to take our visitor from Tord in for questioning. In another version, the man directly told the inspectors that he was from Tord and showed them his passport, but the inspectors clearly did not believe him. The man from Tord tried to convince the inspectors, telling them that his country really existed. According to him, Tord is located between France and Spain. It has existed for about 1,000 years. To prove his claim, he even pointed to a spot on the map that matched the Principality of Andorra. Clearly, things were becoming even more mysterious. They decided to detain him, suspecting he might have ulterior motives. They put him up in a nearby hotel for the night, but they did not let their guard down, even assigned 2 people to keep watch outside his room overnight. What happened next might surprise you the next day. When officials came to his room to continue the investigation, the man had already disappeared. Even more puzzling, there was no sign of escape. Stranger still, all his personal documents had mysteriously vanished as well. If that man from Tord really was a time traveler, or maybe he was an interstellar adventurer. Some people even ventured into the realm of science fiction, trying to find an explanation for this bizarre event. You might not believe it, but there are plenty of people online who see this as evidence of parallel realities. One of the strangest theories is that this man may have accidentally entered a parallel dimension and ended up at this Japanese airport. In that parallel universe, there is an Earth just like ours. It is just that they call it Tord. There is also a theory that this man is a time traveler from the future. However, sorry to burst your bubble, but the most reasonable explanation is the story behind this might just be someone's overly vivid imagination, because there are too many versions of the same story. People may keep adding exaggerated details to it, making it even more sensational. The end? The whole story becomes an urban legend. There is hardly any reason to believe that we have ever encountered time travelers or interstellar travelers on Earth. But in 1994, something strange happened. As night began to fall, no one saw 2 figures opened the emergency exit of the glass-domed biosphere 2 in Arizona. They opened the emergency exit of the glass-domed building, determined to rescue the 7 people who had been trapped inside for a month. They risked their lives to complete this mission. Though the mission was successful, they were prosecuted for illegal entry and property damage. The intruders were Abigail Owling and Mark Van Thillo. They were among the first 8 test subjects. They moved into this place and became lab rats for the experiment. They do not want anyone else to go through the terrifying experiences they endured. It cost $150 million in funding. The experiment was designed to see if humans could create livable conditions on other planets, such as Mars. To achieve this goal, scientists built a miniature world with more than 3,000 species of plants and animals inside. Biosphere 2 is a closed, 3-acre ecosystem with its own mini rainforest, private beach, coral reef, savanna, and wetlands, and even a desert. From 1991 to 1993, nothing was allowed to enter or leave this place. The 8 trapped people called themselves biospherians. They wore matching Star Trek-like jumpsuits, grew their own food, breathed their own air. At first, they were full of hope, enjoying 5-star, hotel-style breakfasts. But after a few months, things took a dark turn. The whole team was starving, and their skin turned orange. In Biosphere 1, which is our real Earth, you can order a pizza in 2 minutes. However, in Biosphere 2, it took them 4 months just to barely make a Margherita pizza. They had to harvest their own wheat for the duff and milk goats to make cheese. Their goal was to be completely self-sufficient and become an independent ecosystem, and they really did become part of the atmosphere. When they breathed, The carbon dioxide they exhaled nourished the sweet potatoes they grew, and those sweet potatoes became part of them, because they were basically eating the same carbon. As a result, they ate so many sweet potatoes that their skin actually turned orange. It was all due to an excess of carotene. It seemed pretty funny at the time, but it actually highlighted a major problem. The crop yields in Biosphere 2 were disappointing, and the team members began to go hungry. They became desperate from hunger. Sudden bursts of anger led them to do many things they later regretted, like stealing bananas. They even had to lock up the refrigerator. In the first 6 months, each person lost an average of 18 to 58 pounds. Every day, someone is responsible for weighing fresh food. 8 kilograms, 26 kilograms. Someone is responsible for weighing fresh food. 18 pounds, 58 pounds. Someone is responsible for weighing fresh food and distributing it to the chefs and entering the nutritional information into the computer to ensure the team meets the recommended calorie, protein, and fat intake. At first, the food is self-serve, but as their hunger grew, the chef began carefully rationing each meal. Their diet mainly consisted of sweet potatoes, carrots, fruit, and the occasional Sunday meat. This was supposed to sustain them through those grueling 80-hour work weeks. But the Biospherians still felt hungry after every meal, and they often dreamed of McDonald's burgers, sushi, Snickers, and cheesecake. The air is running out. The whole place is completely sealed with steel and glass. Steel on top, a solid steel floor on the bottom. The staff makes sure to check every single item that comes in to prevent synthetic materials from releasing harmful gases. The living area is furnished with wood and wool furniture. They could not use chemical deodorizers or blow out birthday candles. The Biosphere residents relied on the food they grew themselves and a large rainforest to produce enough oxygen to keep them alive. However, they were using up their oxygen very quickly. They were almost overwhelmed by their own carbon dioxide emissions. Worst of all, they had no idea why. When there were 9 months left in the experiment, oxygen levels dropped from 21% to about 15%. It was like living on top of Mount Fuji. They felt terrible. Basically, they were dragging themselves around inside the biosphere. They had to stop and catch their breath just to say a sentence. Then, sleep apnea started to appear. Some people would wake up at night unable to breathe. They tried to lower the carbon dioxide levels inside Biosphere 2, resorted to some desperate measures. For example, frantically planting more plants, minimizing watering as much as possible, and even giving up tilling the soil, but nothing worked. So everyone decided they had reached a dangerously low point and asked for help from outside. Refrigerated trucks arrived and began pumping pure oxygen into Biosphere 2. When the oxygen started flowing in, they could not help but burst out laughing and began running around inside. The ecosystem completely collapsed. Hummingbirds and bees disappeared after a few months, and plants were no longer pollinated. Worms and broad mites attacked the crops, and cockroaches took over the entire place. 4 species of cockroaches were introduced to recycle organic matter, but the common household cockroach became the ultimate survivor. They managed to sneak in quietly and breed, becoming a serious threat to the crops. At night, when the lights go out, the kitchen is overrun by cockroaches. Fight these bugs. The team coated coffee cups with lubricant and put papaya inside as bait. The cockroaches would crawl in, but they could not climb up the slippery sides to escape. Hunger, lack of oxygen, and pests are enough to drive anyone crazy. Heated arguments led to cups being thrown, and even people spitting at each other. In the end, the whole team split into 2 factions. They stopped talking and would not even look at each other when passing in the hallway. One group wanted more food and oxygen, hoping to continue their research with some dignity. The other group insisted that they could survive without outside help, no matter what it took, no matter the cost. In fact, the sealed chamber had already been breached. Just 2 weeks later, a Biosphere resident named Jane Pointer accidentally cut off the tip of her finger. While cooking, she accidentally sliced off the tip of her finger. The mission doctor at the time tried to stitch it back, but was unsuccessful. Within days, her finger turned black. She had to go to a hospital outside for surgery. A few hours later, she secretly brought in a bag full of supplies, computer parts, and colored film back into Biosphere 2. She slipped them inside without anyone noticing. It was only months later that reporters found out about this secret delivery. As a result, many people questioned the credibility of the experiment. The media started treating the experiment like a reality show, calling it eco-entertainment of the moment. Headlines around the world made it seem like they were on the verge of dying, to the point that even family members began to worry. They called to ask if the Biosphere residents were really okay. The team felt like they were in a human zoo. Visitors came from afar, gazing at them through the glass enclosure. In just the first 6 months, Over 150,000 people visited the site. Biosphere 2 eventually became a laughingstock in pop culture, inspiring the film Biodome and decades of comedy sketches. You might wonder why they did not just quit the experiment and walk out the door. Actually, not a single environmentalist wanted to be the first to admit they could not handle all of this. Moreover, they still held on to hope, believing they could solve the challenge of building a second Earth. In the end, they managed to find the 7 tons of missing oxygen. It had been absorbed by the concrete, even though chronic oxygen shortage seemed to be their biggest challenge. But the Biosphere resident said, learning how to handle interpersonal relationships in a closed environment was the real challenge. It seemed like the experiment was a huge failure, but the team did gain a lot of valuable experience. They proved that a closed ecosystem could operate for years. They contributed to research on coral reef restoration. Their farm demonstrated high yields and a complete nutrient cycle that could be achieved without using toxic chemicals. If you want to know, Biosphere 2 did not just end there. The second Biosphere 2 experiment took place in March 1994. Now you can go back to the beginning of the video to see how that experiment turned out. Maybe there is another universe, a dark mirror image of our own universe, where time flows in reverse. This inverted world could even be the source of dark matter, that invisible matter that permeates our universe. Might exist in other universes as well. There could be another person exactly like you who woke up this morning but chose to wear a white t-shirt instead of a red one. That choice would lead them down a completely different life path. But let us start with this mysterious dark matter. It makes up most of the mass in the universe. However, we are not sure what exactly it does or where it comes from, because it does not behave like ordinary matter. We can't see it or feel it. We only know it exists because it seems to bend gravity. Even though ordinary matter and dark matter are very different, they seem to coexist in a kind of balance. They exist together. Some scientists believe there must be some connection between the two. A new theory has been proposed. For every motion of ordinary matter, there is a mirror version of it in the dark matter world. It is like a bridge connecting the two worlds. Within ordinary matter, there is also a strange coincidence. The masses of hydrogen and protons are almost identical. This allows them to combine together, forming stable atoms, allows us to see all matter. If protons were just a bit heavier, the balance would be broken and atoms could not form. In a mirror universe of dark matter, things might be different. Maybe the equivalent of protons can't combine with other particles, leaving behind lonely neutrons that could be the source of dark matter. This theory also suggests that dark matter might have its own chemical structure, such as dark atoms, forming a dark periodic table of elements. For a long time, scientists believed there was only one type of dark matter, although these particles are similar in some ways. For example, they are almost invisible. They can differ in size, maybe differences in speed, and how it affects ordinary matter. If this theory is correct, it means that our universe, and the mirror universe of dark matter, may have once interacted in some way. Studying the formation of elements in the early universe might provide us with some clues. The idea of a flipped world has sparked great curiosity in the scientific community in recent years, and even some confusion. Astronomers use a model called lambda-CDIM to explain the composition and behavior of our universe. According to this model, the universe is mostly made up of two things: dark energy and dark matter. Dark energy acts like the force driving the universe's accelerated expansion, while dark matter uses its gravity to pull things together. Big Bang expansion, like the glue of the universe. Ordinary objects like stars, planets, and comets make up only a small part of it. This model also tells us about the process of the Big Bang and how everything began from a hot, dense starting point. The universe has been expanding and changing ever since. Although this model seems correct in many ways, Big Bang expansion, it can't explain all cosmic phenomena. If you draw this model on paper, it looks like a stack of flat pancakes. Big Bang expansion, each pancake represents the state of the universe at a certain moment. The universe from yesterday would be below today's, but it would be a slightly smaller pancake. Eventually, you will see that the history of the universe looks like a giant upside-down cone. The smallest tip is the Big Bang. Beyond this point, we can't look any further back in time with our current tools, so we do not know what is beyond that. More importantly, we are still not sure what exactly happened after the Big Bang, but if we just apply mathematics, the universe might go beyond this turning point in history. It would mean it could go in reverse, creating a mirrored, inverted cone. From our perspective, Time would flow in reverse. This alternative idea not only challenges our understanding of the origin of the universe, but also raises questions about the fundamental principles of physics. All the excitement about the mirror universe also stems from the discovery made by a scientific instrument stationed at the South Planet. This device detected some strange high-energy particles. They seem to be erupting from beneath the Antarctic ice. The problem is that these particles do not behave as the laws of physics would predict. Scientists believe they are a type of cosmic ray. They travel through Earth from space and emerge again. But the particles we know should not behave this way, because higher energy particles usually collide with certain materials inside the Earth. They should not be able to pass through to the other side like these particles do. They seem to be doing something like moving forward and backward. So far, there is no conclusive evidence for a mirror universe. These particles might just be a new type that we have not discovered yet. Scientists need to study them more closely to find out why they behave this way. It is like dealing with a 4-year-old child. But what if it is not just one parallel universe, but many? The concept of a multiverse comes from ideas like inflation theory. The inflation theory suggests that our universe underwent a dramatic expansion in its early stages. Although inflation stopped in our part of the universe billions of years ago, it may still be continuing in other regions of the multiverse, possibly going on even now, creating different universes with their own physical laws and unique features. Ours is the only universe known to be capable of supporting life. For example, we have stable stars, able to provide heat and warmth, which are crucial for the movement of living organisms. We also possess abundant elements, such as carbon and hydrogen. These are essential for our existence. The multiverse hypothesis offers an explanation for why our universe has such life-friendly conditions. It provides an explanation for why, in countless other universes, the existence of life becomes less likely. One fascinating implication of the multiverse theory is the concept of doppelgangers. In these parallel universes, there are exact replicas of ourselves. This concept suggests that in the vast expanse of the multiverse, may be countless scenarios where our duplicates are experiencing similar events. Before we begin to travel to other universes, we might need to first understand the universe we live in. For example, there is a distant galaxy that might not have any dark matter at all. It is about 250 million light-years away, and at first glance seems quite normal. But if we take a closer look, we find that we can't seem to detect any dark matter. If we eventually discover more galaxies like this one, it could change our understanding of how galaxies form. Usually, dark matter is considered essential to this process. It is like the glue that holds everything together. However, indeed, brightness of this particular galaxy is dimmer than usual. It also has fewer stars than normal. When it was first discovered in 2019, scientists thought it might not contain any dark matter. The reason is that it spins too fast. The rotational speed of a galaxy tells us how massive it is. By comparing this speed with the matter we can see, astronomers can estimate how much dark matter it must have. But in this unique galaxy, the math shows it does not have any dark matter. Among all these theories, there is also one that suggests dark matter is not real at all. New research proposes, maybe we have been searching for something that does not even exist. They believe our understanding of gravity might not be good enough to explain why some galaxies behave so strangely. Therefore, they think dark matter is not the cause of these strange phenomena. Maybe we simply do not understand how ordinary matter works. They are based on a theory called modified Newtonian dynamics. This theory suggests that at extremely large distances or very low speeds, gravity behaves differently. A Dyson sphere is a hypothetical megastructure project. It is a massive shell surrounding a star, with platforms arranged closely together, orbiting around the star. It is supposed to be the ultimate solution for energy production and living space. The creators of a Dyson sphere would gain a vast surface area for habitation and be able to capture every bit of solar radiation and heat from the star. The first to propose this bizarre structure was Anglo-American theoretical physicist Freeman Dyson. According to him, an intelligent alien civilization might consider building such a sphere after colonizing the moons and planets of its local star system. As their population grows, these aliens will need more and more energy to sustain their lives. Dyson calculated that if this alien society grows at a rate of 1% per year, their area and energy demand would increase 1 trillion-fold in just 3,000 years. If there are Jupiter-sized bodies in their solar system, they could dismantle them and distribute their mass in a spherical shell. Distance of this shell is twice that between the Earth and the Sun. That much material would be enough to build a huge number of orbital platforms. Each platform could be 6 to 10 feet thick. This would basically allow the civilization to live on the surface, facing the star. Such a shell thickness would be very suitable for habitation, and it could accommodate all the devices that use solar radiation without causing the shell to fall inward toward the star, but after absorbing all that solar energy. The sphere must re-radiate it, otherwise energy would accumulate and eventually cause the structure to melt. This means a Dyson sphere enclosing a star would appear dimmer or even completely dark, depending on how densely the orbital platforms surround the star. At the same time, it would be unusually bright in the infrared spectrum, invisible to the naked eye. That is why a Dyson sphere is classified as a technosignature, a sign of activity. Astronomers can use it to discover whether intelligent life exists in the universe. Some researchers on Earth already have infrared maps of the night sky. They are studying these maps in hopes of finding a Dyson sphere. So far, no one has found one, but one study has identified several Dyson sphere candidates. The researchers used a special data processing pipeline to combine and analyze massive amounts of information. One of the main search criteria is detecting excessive infrared radiation. It is also crucial to distinguish this radiation from that emitted by natural objects. After a complex screening of millions of objects, researchers identified 7 potential Dyson spheres, although further analysis is necessary to determine their nature. To this end, scientists plan to use optical spectroscopy, which may reveal more details about these objects and their origins. At the same time, researchers also acknowledge that these Dyson sphere candidates may have other explanations. For example, they could be debris disks or protoplanetary disks around young stars. Only further research can show whether we are able to find traces of other civilizations in the galaxy. So far, this remains an open question. Interestingly, Dyson spheres are widely discussed in science fiction. As early as 1937, Olaf Stapledon's novel Star Maker described a system in a particular galaxy surrounded by light traps, which concentrated solar energy for intelligent beings to use. As a result, the brightness of the entire galaxy was dimmed. In another novel, Ringworld, the author mentioned a ring-shaped artificial structure built around a star. This is the James Webb Space Telescope. This is the range it can see through its eyes. Very impressive, but let us zoom in a bit more. And a bit more. And a bit more. The image gets blurrier and blurrier. Wait. What is that shadow? That is a giant telescope. It can see those seemingly blurry images in perfect detail. NASA's Roman telescope will launch in 2027. It may help us unravel the mysteries of the universe, including the nature of dark matter. Rest assured, the James Webb will continue to reveal the beauty of the universe to us and solve its mysteries one by one. But now astronomers have a new mission. They hope to deploy the next, even larger space telescope. This mission is already well underway. The Nancy Grace Roman Space Telescope is likely to usher in a new era of astronomy. Scientists hope that the data collected by this telescope will surpass the total from all previous NASA missions. The Hubble and Webb space telescopes excel at magnifying and capturing clear, detailed images. But the Roman telescope will provide us with a much wider field of view. It will be able to capture infrared images 200 times larger than those of Hubble. At the same time, it will also have the same high level of detail. But even if the new telescope can provide perfect images, its main purpose is still to conduct large-scale surveys. Suppose we need to search for groups of stars in nearby galaxies, but that is too wide a field of view for Hubble. If we use Hubble, we would have to stitch together multiple different images into one large picture. With Roman, it only takes a single shot to capture a panoramic view of an entire galaxy. Take a look at this mosaic of our nearest neighboring galaxy, the Andromeda Galaxy. This image was stitched together from 400 individual photos taken by Hubble, but Roman will be able to capture the same ultra-wide image with just 2 shots, with the same level of detail. Not only does that sound cool, it also means an unprecedented amount of data. Once we have a panoramic view of the universe, NASA and other space agencies may be able to answer some of the major questions that have long puzzled humanity. One of the main goals is to test Einstein's theory of relativity. This theory has been well verified on the scale of our solar system, but it has not been thoroughly tested on larger cosmic scales. According to this theory, visible matter should slow the expansion of the universe. Yet the universe keeps expanding, and it is expanding faster and faster. Therefore, astronomers attribute this increasing rate of expansion to a mysterious component, dark energy. They believe dark energy makes up about 68% of the universe. They hope the Roman telescope will provide us with data to help us accurately measure the positions and distances between us and millions of galaxies. Ultimately, it may allow us to figure out the rate of expansion in different regions of the universe. In the end, the results may tell us whether Einstein's theory of gravity needs to be revised. Another main goal of the Roman telescope is to detect hundreds of new exoplanets within our galaxy. The telescope will use a technique called gravitational microlensing. You see, when two stars align, the star in front will bend and magnify the light from the star behind it. The star in front has a planet. We can observe how that planet affects the light from the star behind. Roman aims to calculate for billions of stars, giving us excellent statistical data on how many of these stars have exoplanets. This cutting-edge telescope will not only discover new exoplanets, it will also carry another crucial tool. It is called a coronagraph. It can image exoplanets that are close to their parent stars. In fact, this is an extremely complex technology because it has to suppress the light from the star. After all, stars are much brighter than the objects you want to study. The coronagraph on the Roman telescope will attempt to directly capture giant planets like Jupiter, perform real-time calibration to improve image quality. If it works properly, then this will become a great demonstration tool, laying the groundwork for technology on future space observatories. These telescopes will be able to directly capture Earth-like planets within the habitable zones of stars. But the Roman Space Telescope is not the only project that could change the way we explore space. There are other concepts, such as Poseidon. It is based on a new technology, a revolutionary space telescope design using special optical elements. These optical elements could help us overcome the main limitation of space telescopes, the non-expandable primary mirror. Poseidon's technology could provide a large but ultralight telescope aperture. This makes it possible to launch a massive fleet of identical telescopes. They will have impressive light-gathering capabilities, helping Poseidon investigate thousands of Earth-like planets in the habitable zones of stars. Ultimately, we may be able to find signs of life in the atmospheres of these planets. Over the past 2 billion years, Earth's atmosphere has undergone dramatic changes, with an abundance of free molecular oxygen and ozone. These highly reactive gases, along with water vapor and methane, they form a unique atmospheric composition. The presence of these gases in Earth's atmosphere are biosignatures that can be detected from afar, and we are not talking about up close, but across galactic distances. But to identify the fingerprints of these atmospheric components in the light reflected or transmitted through an exoplanet's atmosphere, we need a really large telescope. NASA's Kepler mission has discovered over 4,000 planets, but so far, none of the existing or planned space telescopes have a large enough diameter to search for life in the atmospheres of exoplanets. Detecting and correctly interpreting signs of alien life is extremely difficult, but the Poseidon team hopes to build one, a telescope capable of studying thousands of Earth-like planets. Next up is the European Space Agency's Euclid mission. Its goal is to explore the composition and evolution of the dark universe. This mission is named after the ancient Greek mathematician Euclid. He lived in Alexandria around 300 BC. He founded geometry, and because the density of energy and matter is closely related to the geometry of the universe, this mission is also named after him. This space telescope will create a grand three-dimensional map of the large-scale structure of the universe, spanning both space and time, a magnificent 3-day map. It will observe billions of galaxies, covering more than a third of the sky. Euclid will try to figure out how the universe has expanded, and how its structure formed throughout cosmic history. Hopefully, it will reveal more about the nature of gravity, dark matter, and dark energy. As we know, dark energy is most likely accelerating the expansion of the universe. As for dark matter, it controls the growth of the universe's structure, but experts are still uncertain about the exact nature of dark energy and dark matter. By observing the evolution of the universe over the past 10 billion years, we might finally figure out how it has expanded and changed. With this data, astronomers might be able to infer the properties of dark energy, dark matter, and gravity. This could help us understand their true nature more precisely. The Euclid space probe is about 15 feet tall and 12 feet wide. It consists of two main components, the payload module and the service module. The payload module includes a telescope with a diameter of 4 feet, two scientific instruments, a visible light camera, and a near-infrared camera or spectrometer. As for the service module, it contains the satellite systems, such as power generation and distribution, data processing electronics, thermal control devices, and so on. One of the reasons space is so terrifying is its unpredictability. Even though 99.9% of the universe is empty, if you do encounter some kind of matter, you can be almost certain it could easily end your life. And some things are more frightening than others. For example, gamma-ray bursts. When a galaxy explodes, it releases powerful gamma rays. These rays can completely destroy any asteroid or planet in their path. In our galaxy, A gamma-ray burst occurs about once every 5 million years, and then there are vampire stars. Scientifically, they are known as O-type stars. These are massive blue giants that feed on much smaller stars, gradually consumed by the gravity of their massive neighbors. But the lifespan of a vampire star is not long. Once a vampire star in space has devoured a smaller star, it will explode from the gravity within itself, become a supernova. Black holes are both fascinating and terrifying. They consume any matter that comes close and distort the space-time around them. Can they get even more terrifying? Absolutely. When we talk about rogue black holes, they can be even more terrifying. One rogue black hole discovered in 2016 is heavier than the Sun, and it is moving at over 1,240 meters per second. This black hole may have broken away from its home galaxy after a collision with another galaxy. Currently, it is about 2 billion light-years away from us. What about the Great Attractor? This is a mysterious region of space anomaly. It is 150 to 250 million light-years away from our galaxy. The gravitational pull of the Great Attractor is so strong that it can draw in entire galaxies, causing them to collapse into each other. But the scariest part is, we still do not know what it is, whether our galaxy will eventually fall into its clutches. Meteors might not sound particularly exciting or frightening, but they are actually one of the most real threats to our planet. Every year, thousands of meteors hit the Earth. Fortunately, most are too small to cause any serious harm. They either burn up in the atmosphere or fall into the ocean. Our sun can also be incredibly terrifying, especially when it releases powerful bursts of energy. Solar flares. Solar flares are often accompanied by coronal mass ejections. Those are massive bubbles of charged gas. They can accelerate to incredible speeds. Even the most powerful volcanic eruptions are nothing compared to the energy released by solar flares. It is simply insignificant. Energy released by a solar flare is 10 million times greater than the most powerful volcanic eruption. In just a few minutes, a single solar flare can release billions of tons of charged particles. The temperature of a solar flare is also extremely high, reaching several million degrees. Astronomers believe that when certain regions of the sun's magnetic field become twisted, a solar flare occurs. At a certain moment, all the accumulated energy is released. The star emits light and particles outward, mainly electrons and protons. Most solar flares last a few minutes, but some can last for several hours. Intense solar storms could potentially cause catastrophic global blackouts on Earth. The next terrifying phenomenon is the dark flow. All galaxies should be moving away from each other evenly. There is a large cluster of galaxies that appears to be moving at 600 meters per second, moving toward a small region between Lyra and Draco, for no apparent reason. That is why this inexplicable phenomenon is called dark flow. The universe also poses many dangers to astronauts. For example, extended space travel clearly alters human DNA. Scientists believe that the stress of long-term stays in space may cause astronaut cells to rewrite their genetic code. The worst part is that this kind of DNA change is permanent.